The last video for this section focuses on how we denote the first derivative, different ways of writing the first derivative, but also second derivative, third derivative, fourth derivative, on and on. We are actually able to take the derivative of any function. So if we've taken the derivative and we have something written out for a first derivative, I can actually keep taking derivatives of the derivatives. And you'll find as we get into chapter 4 eventually that there are lots of uses, especially for first and second derivatives, that will help us with graphing. So just some things about how we denote different styles of denoting derivatives. We're pretty familiar with the first row, hopefully, but as we move on, we say now we've taken the derivative of derivative. We just use 2 apostrophes for this form, 2 apostrophes there. For this version of writing it, we put 2's, but notice that the 2's are in slightly different places. There's a technical reason for it. I won't worry about it too much. And then we use this one a little bit, and we just, the 2's, it's almost like you're squaring it. It continues for the third derivative, fourth derivative. We have a slight change. When we get to this method now, we don't use apostrophes anymore. We actually use numbers, but we have to put the numbers in parentheses, otherwise we might think we're raising it to the 4th power. So this is useful just for certain types of questions. You know how many derivatives you need to take. So let's practice taking some derivatives. This question is asking us to find the 4th derivative of this function. It won't be too bad. We're going to use the power rule quite a bit. So now we have the first derivative. Once you've applied the power rule to each part, you'll end up with that. And just think of that as another function, and you're going to take the derivative again. So now we're finding the second derivative, and you'll keep applying the power rule. So I'll just kind of walk you through this one. You'd have negative 280 as your coefficient, x to the 6th plus 60 x to the 4th minus 54 x to the 1st, or just an x. Third derivative, so 3 dashes now. Boy, you might need a calculator for that. I'll quick look at my key here. You get negative 1680 x to the 5th plus 240 x to the 3rd minus 54. Oops, let me erase that there. Minus 54. And now the 4th derivative, so the way that I'm writing it, now I put a y, and now in parentheses I put the 4 down. And once I get that, I'm going to get negative 8,400 x to the 4 plus 240 times 3 is 720. And we have an x squared. So in the end, this would be my answer. You just keep taking derivatives of derivatives. So the previous example was easy because we just kept using the power rule. In this case, we're going to find the second derivative, but notice that the beginning function is a little bit more challenging. We have to use the quotient rule. And so this is one where knowing how to simplify an answer might make taking your second derivative a little bit easier. Okay, so let's start by finding that first derivative, and for this, remember, we want to go low, x minus 1 times the derivative of the high one, so derivative of x is 1, minus high times the derivative of the low one. Derivative of the low one would just be a 1. And then we're going to square the low. So I have x minus 1 squared. So that technically is the first derivative, but if I need to take the derivative of this thing, I want to simplify it first. So if I were to go through and simplify all of this in the numerator, I would have an x minus a 1 minus an x. And on the bottom, I could FOIL this together if I wanted to. I think in the end it's going to be a little easier just to leave it as is. Nope, I take that back. For what we're going to do right now, I think for my last step I'll simplify that one more time. We could leave it that way if we knew one more rule, but we're not quite there yet. So, last step, in the numerator I'm going to have a negative 1, and in the denominator, if I think of going x minus 1 times x minus 1, I would end up with x squared minus 2x plus 1 in the end. So that's a much easier version of the first derivative. So now I'm going to take the derivative of that to get my second derivative. So remember, it is, again, we have to use the quotient rule here. We're taking a function divided by another function. It's going to have the low, so x squared minus 2x plus 1, times the derivative of the high. Derivative of a constant is 0, so times is 0, minus high, so minus a negative 1, times the derivative of the low, and that would get me a 2x minus 2. And then I'm going to be squaring the low. So I'm going to have x squared minus 2x plus 1 being squared. Okay, as I go through and think about how I'm going to simplify this, my numerator, let's work through that first of all. The whole first chunk is just going to be 0, so I need to basically think about distributing the negative 1 to both parts, but also realizing that I'm subtracting it. So maybe what I'll do is even think of, basically these things are going to cancel each other out. In the end, that's what would happen. So really I'm just going to be left with a 2x minus 2 on the top. Then our denominator, I'd be okay just leaving it like that, but I just want to maybe walk you through some more complicated algebra, so don't worry about this part too much, even though it's just good to kind of keep in the back of your mind. Remember that this right here was really, just the inside part, was really x minus 1 being squared. So the inside part is x minus 1 being squared, and then we're squaring it again. So really what I would have here, if I chose to do it this way, I'd have x minus 1 being raised to the 4th power. And the reason I'm doing that is I can simplify this even more if I catch that, and it might be helpful just to realize that. What I can do is I can factor a 2 out of both parts in the numerator, and I'd be left with x minus 1 behind. And then in the denominator, instead of writing it as to the 4th power, I'm going to have to the 3rd power, and then take one of them and just write it behind. And now I'm able to cancel this out, and my real, probably most simplified answer is going to be 2 over x minus 1 cubed. If you did not see that coming, that's not the end of the world, but just something for you to think about how you can work through some trickier algebra. Okay, last example. Basically, they're telling us what the 4th derivative is, and they're asking us to find the 5th derivative. Just kind of showing you that you can really apply this idea of derivatives starting at any level. So from the 4th to the 5th just means take one derivative. I might start out by rewriting the 4th derivative. So y, or the 4th derivative of y, is really 2 times x to the 1/2 power. So now I can use my power rule, so that means that the 5th root, not the 5th root, the 5th derivative, if I use the power rule, I'm going to bring the 1/2 down, times the 2 is just a coefficient of 1. Really I'm just going to be left with x to the negative 1/2, which if we practice our power rule is really just 1 over x to the positive 1/2, which is really just 1 over the square root of x. It's an algebra fantastic. Okay, we are done with section 3.